Science 20s. This is Mr. Riley here. This is, I guess, our first lesson in our digital classroom. I hope all of you guys are doing okay. I wish I could show my face on the video, but then I can't really write on my tablet here, so we're going to just do it like this. This is the first of a couple little review lessons for physics. We're just going to start looking at significant digits first. I know you all love worrying about sig digs, but in physics, it's something that's important for us to do. So just a couple rules for sig digs. First of all, the rule regarding leading zeros. So when I say a leading zero would be any digit that's in front of a non-zero digit. So those first two zeros in this number are leading zeros. These are not significant. Trailing zeros, these are the zeros that would be at the end of your number after any non-zero digit. So that would be these two zeros here. Now these are significant for us to worry about. And then our third rule is that all non-zero digits, so the ones here, and any zeros in between non-zero digits are all significant. So in this number, how many sig digs do we have? We have one. Oops. What's that? Get out of here. Sorry. 2, 3, 4, 5 significant digits. So in this number here, there's 5 sig digs. Okay, so take a look at this example here. How many sig digs are in each of these numbers here? So the first one here, I have 0.04050. So I have two leading zeros. Those are not significant. All of my non-zeros are always significant. Any sandwiched zero between non-zeros is significant, and my trailing zeros are significant. So this one has 4 sig digs. And what about this next one here? Obviously the 5 is significant. Okay, this 0 is sandwiched in between two non-zeros, and then this 0 at the end follows a non-zero, so that's significant. Now this exponent right here, and this times 10 to the negative 2, none of this is significant, so we don't need to worry about any of that. So this one number also has 4 sig digs. Okay, let's move on to scientific notation, then we'll put those things together. So in order to put something into scientific notation, you need to turn it into a decimal number between 1 and 9.9 repeating, followed by times 10 to the power of whatever. Okay, so on our first one here, my decimal is here, and I need to change this number into a number between 1.0 and 9.9. So I have to move this decimal 1, 2, 3, 4 places to the right. And so this number is actually going to become, I'm going to put that decimal there, it's going to become 3.29 times 10 to the, now how many jumps did I make on my scale here? I made 1, 2, 3, 4. So my exponent's going to be 4, and since I went to the right, that's going to be a negative. Now, one thing you can just think of is small numbers. If a number is less than 1, it's going to have a negative exponent. Okay, so don't worry about the direction. If you have a small number that's less than 1, your exponent's going to be negative. So this number right here, our decimal starts here, and I need to make this number between 1 and 9.9. So I need to bring my decimal this place, 1, 2, 3 places. So my new decimal is here. My number is going to be 5.0253, don't forget the 3, times 10 to the, and I move this decimal 1, 2, 3 places to the left. So I'm going to have a 3 for my exponent there. Okay, that's how scientific notation works. Just remember, small numbers will have a negative exponent. Big numbers will have a positive exponent. Now, to put this stuff together, when I'm doing a physics problem, there's a rule. When I have multiplication or division in my question, I need to use the value with the least number of sig digs to determine the sigdigs in my answer. So for example, with this question, I need to take 5.24 times 10 to the 3 and multiply it by 9.1. So I'm going to take out my calculator. I'm going to do 5.24. Now for my exponent, I'm going to use second function comma here for this e times 10 to the 3. And I probably should use brackets, but let's see if this works. Times 9.1. And I get this number here. So I get 47,000, what was that again? 47,684. Now I need to round this to the least number of sigdigs from my question. So I see 9.1 here has 2 sigdigs. The 9 is significant, the 1 is significant. So I need to change this number into 2 sigdigs. So how the heck am I going to do that? Just like I did before. I'm going to take my decimal, which happens to be right here at the end, and I'm going to move it 1, 2, 3, 4 decimal places to make this number between 1 and 9.99. So my new number is going to be 4.7684 times 10 to the 4. But I got a problem. I need 2 sigdigs. So I'm going to round this. There's my 2 sigdigs. I need to look next door to see if I have to round that 7 up or keep it the same. The 6 tells me I have to round up. So this number is going to become 4.8 times 10 to the 4. Okay? A lot of steps in there for something that seems simple, and we want to make sure we're doing this without mistakes, and that's why we practice it. So I want you guys to try this question right here and give me the answer to the correct number of sigdigs. So pause the video. Do it now. Pause it. Pause the video. Okay. So hopefully you have an answer now. So we're going to do this on my calculator here. We got 2.7. I'm going to start a bracket this time. 2.7. Oops. Try this again. 2.7 times 10 to the power of 4. And I didn't do a bracket again. Multiplied by 0.030. Actually, the good thing about using that e function, if you have it on your calculator, is you don't have to actually use brackets, and it should sort of worry about that for you. So my answer I got here was 810. Okay, great. I'm done, right? Nope. I have to round this to how many sigdigs? Well, this number has 2 sigdigs. And this number has, that's not significant. That's not significant. Yes, yes. This number also has 2 sigdigs. So I need to round this to 2 sigdigs. All right, well, I'm going to move my decimal place from here 2 places to the left. And that means my number is going to become 8.10 times 10 to the 2. And I need to round this to 2 sigdigs. That 0 tells me I can keep my 1 the same, so I'm just going to drop that 0 and get 8.1 times 10 to the 2. Okay, hopefully that helps you out. Good luck.